Hello guys, this is Jacob. Today I'm making a video to show you guys how to build a local AI engineer using Aider and Qwen2.5 with Ollama FastAPI that are set up on Kaggle GPU. And hopefully this is interesting. And if you are interested, then let's continue. So that being said, let's get started. So first, go to Aider.chat Ollama page. So basically they have a setup steps that you can follow, but instead of using the Ollama API base with the local host, we will set this up on Kaggle. So you can actually connect your local Aider instance to a remote Ollama FastAPI service that's running on the Kaggle GPU. So, and that's what we're gonna talk about today. So, and then let's go to the Ollama model, the Qwen2.5 coder. Right, so they basically have a lot of the different tags. So in this demo, we're going to use the 14B. You can also choose the other models like the just recently released 32B, 2-bit model or 3-bit model. That's also cool, but we're going to test or demo this on the 14B of the Qwen2.5, which is good enough. So let's continue with the Kaggle. So this is what I'm going to build today. So just create a notebook. Let's call it Ollama FastAPI Aider. So we just create a function actually to run bash command within Python, and then we download Ollama, and after that we just spin up Ollama. Very straightforward. So then you can see Ollama is running on the GPU, right? So basically this is the P100. So we're gonna basically test this on the Qwen2.5 encoder 14B, right? So do an Ollama pull on Qwen2.5 encoder 14B. You can use the other ones like 32B, 3-bit or 3-bit medium, 3-bit small, or you can do a 2-bit also, because those are the ones that are gonna fit into the Kaggle 16 gigs of VRAM. Right? So if you choose a bigger one, then Kaggle will not support that. So I think 14B is about only 9 gigs. So but you can check that. And after that, just do Ollama list to show basically the Ollama has the Qwen2.5 coder installed. So you can see the size is 9 gigs. So that I was right. So it's about 9 gigs. And after that, you can build a FastAPI service using the Python script. So we have to install the FastAPI unicorn and request Ollama async.io and OpenAI. And after that, just do a SSE startlet. The reason to install that is because when we build the FastAPI, we need the streaming, right? So if you connect Aider with the FastAPI service, then you need a streaming endpoint instead of just a regular REST endpoint. So that's why we installed the SSE startlet. This gives you the response as a streaming response. So that's all. And then after that, you create a function called a Kaggle working main. So you can name whatever you want, but I just call it main.py. In this function, we create an endpoint called a path and pass. This is a very generic endpoint. So basically, this takes any request, right? So because you don't know what endpoint the client will use, right? For example, Aider or Cloud Dev, they use different endpoint. To make it generic, so basically we just want to see all these different AI coder client and which endpoint they're calling. So I'll just use a very generic one, which is path. So every request will fall into this endpoint. And also we make the payload as generic as possible so that we know, what kind of payload those client, AI coder client will basically send, right? So that's why we make both very generic, so you see things very clear. And we created a function called generic data, and also like we try to also dump the payload so that we know what the payload is just from the logs. And make sure that you do the model check, because sometimes they don't send the model. I think it depends, but just do a model check. If the model is not in payload, we just skip that request. So and then we just get the model name and the prompt from the payload, and also basically this is an example if you actually need this for like some type of streaming, but or chat response, right? The OpenAI support actually chat and also generate. Aider uses generate endpoint. So but this is not needed though. Let's just comment that out. So basically we just use the message which is gonna be passing into the OpenAI Python API. So you can see here basically the message is passed to the Ollama generate function. So Ollama would basically take the model name and also the message, which is the prompt, and also do a streaming for the true. It will generate the response as a stream. And also basically for each of the chunk in the stream, you just check if the chunk is valid, right? And also just do a yield of the partial message of the basically it's a chunk and turn that to a JSON stream. And after that, we just do a streaming response like that. This is the reason the event source response is the reason that we actually installed SSC startlet. You can see here the SSC startlet. We basically import this event source response so that you can actually have a streaming response. We don't use the streaming response or JSON streaming response as a default, but because that somehow doesn't work, so we have to use the event source response. The catch is that if you use the event source response, the response payload will have a data as a prefix. We'll talk about a little bit later, but you have to basically do a little bit refactoring so that you can have the content in the data, not the entire response. You have to basically take whatever the data has. They do have a basic data as a name or a field name that tied to this, but we'll show that later. And make sure the meta type is tags and event stream. And after that, basically you start Unicorn on the 8000 port. So that's all. So after it's spin up, and you'll basically be able to tie the Aider to this RESTful service, right? So before you do that, make sure you install Ngrok. So we talked about this many times. This is basically to turn everything out inside the notebook to the outside. So basically everything with public URL. It's not a local host or like an internal notebook URL, but everything's public, as we will see later. And basically you just get the Ngrok token from Ngrok console and paste it here. When you actually hit enter, you will set it in the Ngrok app, basically. And also make sure you point your Ngrok public URL, which is this one in this demo, to your localhost 8000. Okay, so basically this is where localhost 8000 is set. So make sure that you tie the public URL to the local 8000, which is your FastAPI basically endpoint, right? So, and after everything's set up, just do a uvicorn main.app and do a reload. So this will actually spin up the RESTful service, so that you can see here it's basically spin up on 8000. So the endpoint will be on this temporary public domain. So you can use this in the Aider, basically the Aider Ollama API base, which you saw here, right? So set up in here, and then you will basically use this on your local client. So this has already been set up. So let's go to the local Aider. Right, let's go to local Aider client. Okay, so here's the Visual Studio. So you can test it in any ID you want, but we're gonna demo this on Visual Studio Code. So first, you have to set up the Ollama API base just to export Ollama API base, and which is the endpoint we just saw, right? 0AEC. So let's just double check that. So you can see this is on 0AEC. Okay, good. Let's go back to the Visual Studio Code. So after you set up Ollama API base, just do a Aider -- model, and basically you pass in the Ollama model. So that's the Ollama model. And let's hit enter. Right. Okay. So basically, you'll get a prompt saying that you add a git ignore. So we don't want to add that right now. Just click no. And then basically they say, okay, do you want to open documentation URL? And say no. So okay, then you can start coding. Let's do some very simple test, right? So is 3307 a prime number, right? Very simple. Let's see how it works. So just wait a bit, and I'll basically see the streaming coming out, right? So those are the streaming response. And let's start coding. Okay, so, and basically they're saying that there's some issues that basically auto-correct everything. Okay. and then say, do I want to create a new file? Yes. So let's create a new file. So you see the new file is created in the check prime on the this folder. Right. Okay. Let's just check if it's working. So you see the check prime is created. So let's just do a type Python and check prime. Let's first actually take a look at what check prime is, right? So you can see that the check prime, they basically had a function called is prime, and then the deposit number as 3307, and then that number will basically be called in this function, and then output the response is a prime number or not prime number. Let's do the Python check prime, right? The py. You can see is a prime number, which is correct. So the first test is passed, so which is awesome. Let's do a second test, right? Let's do a second test. Oh, by the way, so before we go further, we'll just make sure that when you test the Aider response, you have to also make a change on your Aider client side. Stream, so it's called a handle Ollama stream. So basically, you, as I mentioned earlier, because there's a data prefix in the REST FastAPI response, so you have to basically remove that data prefix. So just take the content. So we just do a regular expression, basically, and take out the data field. I just do regular expression. So the REST one response result one is basically the content from the FastAPI streaming response. So just content, take the content, put it into a object, and that's it. So this is the change that you have to make on the client side, but that's all. Let's go back to the test, okay? And the second test I want to try is this, maybe create a Python game. Let's say call it the snake game, right? So let's call it, just go back to the model again. Let's say I still no, right? And no, we don't create that, but create a snake game using Python. Okay, that's it. Right, so basically they have to install Pygame, so they ask you to install it first before run the Python script. So while we're waiting for the program to build, let's just do a quick look at the Kaggle notebook, because it's actually generating logs, which I think is helpful to you. Let's go back to the Kaggle notebook. So you can see basically it got all these different payload from the Aider client, right? So this is helpful when you actually try to debug, because everything is show exactly how the Aider works. So let's go back to the Visual Studio again. So it's still going. So real cool, and let's just click yes. Let's create a file. Right, it's called a snake game. Let's click on that. Okay, super nice. Let's just give it a run to see if that works. Okay, let's see. Okay, let's start running this. Okay, let's just do Python and snakegame.py. And then let's run that. Okay. So, okay, the program started up. Let's go to this program. So, okay, this is basically the Python game that we just built. So, let's test it out. So nice. It's a good job, right? You can see that it run very nicely. Okay, it's lost. Press Q, quit, and C play again. This is cool. Okay, let's close that. It's very nice. Let's go back to the Visual Studio Code. All right. Let's go do another question. Okay, let's do another question. Let's create a minesweeper game. Right? Let's create a minesweeper game. Using the same strategy. Okay, so we still we don't want to create a git no, and then we don't want a documentation. Just create a minesweeper game. Okay, let's hit enter. Okay, it starts running. Okay, create a new file. Yes. All right. So let's test it out. Okay, let's test that out. Okay, let's just do a Python and minesweeper. So okay, this is really cool. So it's actually in the terminal. So let's just say add a row. Let's say do a 5 and 5, and the row 5 and 5. See? Okay, it's cool. And I just do 0 and 1 and the row and okay. Oh, that's really nice. So game over. So that's actually a hidden mine. So this is really well written, right? So you see that actually we didn't make any changes. So just working right out of the box. So this Qwen2.5 is really awesome. So please try that out. So the next one, or maybe the last one that I want to test, is the web page. I want to build a web page using Qwen2.5 and with the Aider. So let's do that. I still know add environment. We don't want to do that. We don't want to open documentation. Create a AI company landing page with HTML, CSS, and JavaScript. Right, and let's do that. And JS. Okay, let's do that. Okay, create a new file. Yes. Create a CSS. Yes. Create a JavaScript. Yes. Okay, you can see on the right side, so everything's created. Let's open it up to see how that looks like. Let's go back to the Chrome browser. Okay, as you can see, this is actually created nicely. So you can see that's actually have a different sections, about section, they have a service section, and they have a contact section, the get started section. So all right, this is really nice. Okay, and the design is nice too. You can see that the design is fairly good, right? So you can put the images here, and it's a pretty bold design. So I will say Aider with Qwen2.5 is actually nailed all the questions. Like they get everything correct, just right out of the box. You don't need to make any edits, right? You can see that, right? So that being said, hopefully this is helpful. And if you like this video, please click subscribe, like, or comment if you have any questions. Thanks for supporting the channel. See you in the next one.